Hey everyone, Dr. Mungli here. So if you haven't subscribed to my channel, so kindly consider subscription so that you get a regular notification whenever I upload a new video, and also don't forget to click the bell icon for the notification. So in my previous videos, so I have made a video on dietary fuels, and basically in that particular video I have explained like how the catabolic pathways will support anabolic pathways. So the very basic basis of metabolic pathways I have explained. So kindly watch that video. The link for that video is there given in the description below, and also it is appearing in the upper right corner right now. So this video is the continuation of my previous video on dietary fuels, so kind of it's a part 2 of dietary fuels. So what I'm going to explain in this video is I'm going to explain how much is the energy that comes from carbohydrates, proteins, lipids, and also alcohol, so that we know how to calculate the amount of energy that is given by these major food macromolecules. And also of course I will explain you about the energy that come from alcohol metabolism. So before that, like how do we express energy that come from the metabolic dietary fuels? So the energy that is coming from the fuels, it is expressed as calorie. So what is calorie here? So the calorie, it is the amount of energy that is required to raise the temperature of 1 liter of water by 1 degree centigrade. That is referred as 1 kilocalorie. So it is a kilocalorie actually. So 1 kilocalorie is the amount of energy that is needed to raise the temperature of 1 liter of water by 1 degree centigrade. So why don't we write 1 kilocalorie? Whenever we look at like food packets or anything, so the calorie is simply written as like calories here, something like that. So why do we write calories? So why we don't write like kilocalories and all that? So note that, so when we started to express the units of express the amount of energy that come from the catabolism of certain food or the food molecules, so it started as like kilocalories only. As we started as kilocalories, and also it was usually previously it has is to write it as like uppercase or the capital C here and mention it as calories. So eventually what happened is, so the kilocalories we started to express simply as calories with uppercase C, and as this word became popular, like calorie become popular, so we just like dropped that uppercase C and just written like just C, calories. So the calorie or calories here actually meant kilocalories. Always remember, whenever you read something as calorie, so just remember that we meant kilocalorie. All this is same, like kilocalories, calorie and calorie, because the term became popular, and we just simply write it as calories. So now I told you, so whenever you read it as calorie, so it is actually kilocal. So that's what it is. Now let's move on to see how much is the energy that will come from oxidation of carbohydrates. As you know, like our major carbohydrates in human diet are starch, which is coming from plants, or major other carbohydrate that will be present in our food, like depending on whether or not we use table sugar. So that is sucrose is the other carbohydrate. And then the milk sugar, as you know, is lactose, is a type of carbohydrate, and also high fructose corn syrup. So the fructose is a monosaccharide that will be present in our food, and it can be directly glucose. So what happens to the polysaccharide starch that is present here coming from plant source. So starch, as I have given the structure of starch here. So as you can see here is this is the structure of starch. So you can see that each glucose molecules are joined by alpha 1,4 glycosidic linkase. So alpha 1,4 glycosidic linkases are given here, and wherever there is a branch point, so that branch point is made with alpha 1,6 glycosidic linkase. So basically glucose molecules, they are all attached with one another, making an amylose component, amylopectin component. So overall, if you look at this polysaccharide here, so there are a lot of oxygen molecules which are present in a carbohydrate. So all these hydroxyl groups which are present in the glucose molecules, so a lot of oxygen there. Now when this polysaccharide starch is digested, so it will be digested into glucose, simple monosaccharide glucose, and whenever sucrose, which is a disaccharide, when it is digested in your intestines, you are going to get glucose and fructose, and when the milk sugar lactose is digested, so we are going to get again glucose and galactose. So these are the monosaccharides that we get after the digestion of polysaccharides and the disaccharides. So overall, the predominant monosaccharide that we get is the glucose molecule. So glucose molecule is a monosaccharide which is the predominant sugar in human blood. So oxidation of this glucose molecule into carbon dioxide and water molecules, so in the body it produces approximately around 4 kilocals per gram of carbohydrate, or you can just say 4 calories. So 4 kilocalories are the 4. So 4 kilocalories per gram. This is the amount of energy that you get from oxidation of carbohydrate. 1 gram of carbohydrates give you 4 kilocalories of energy. In other words, every gram of carbohydrate we eat yields approximately 4 kilocalories of energy. Note that the carbohydrate molecules contain a significant amount of oxygen, as I already explained you before. Each glucose molecule we have a significant amount of oxygen there and are already partially oxidized before they enter into our body, because these oxygen molecules are already present in a glucose molecule. So this is already oxidized, partially this is oxidized. So this kind of oxidized molecule is entering into our body. So since it is partially oxidized, the amount of calorie that you get from the oxidation of further oxidation of carbohydrates into water and the carbon dioxide molecule gives you relatively less calories compared to other molecules which we are going to see later. So that's about carbohydrates. So let's move to see proteins. Now the proteins are composed of amino acids that are joined in the form of a polypeptide bonds. As you can see, this is the let me show you. Here is one of the amino acid and then the other amino acid, as you can see. So the two amino acids, so basically in this polypeptide chain there are 3 amino acids. See, there are 3 R groups which are the side chains. This is an alpha carbon here with the amino group, and we have a carboxyl group. Now the carboxyl group of the first amino acid is going to interact with the amino group of the next amino acid and make a peptide bond, that is CONH covalent bond here. Like this, amino acids are joined with one another and making a peptide bond. Now the point here is as this peptide bond formation will go on, so you look at the nitrogens that are present here. So each amino group, each amino acid has this amino group, and amino group is basically it's a nitrogen. So if you look at the protein molecule, so protein contains approximately 16% of nitrogen per gram by weight. So 16% of nitrogen is present per weight of this protein. So if you weigh the protein, so basically 16% of that is the nitrogen. So that means protein is one of the major source of nitrogen for us, for whatever the need of nitrogen is there in our body. So the digestive process in the intestine breaks proteins into individual amino acids. So basically proteins are digested into amino acids, and these amino acids will undergo metabolism. So and they enter into the blood, and just in case if the amino acids are oxidized, so the oxidation of proteins into amino acids and further into carbon dioxide, water molecule and ammonium ion NH4 plus, all that will give rise to 4 kilocalories of energy per gram of protein being oxidized, 4 kilocalories per gram. Again note that this is similar to the oxidation of carbohydrates. Per gram of carbohydrate give 4 kilocalories. So in the same way, oxidation of proteins also per gram gives 4 kilocalories, because already this is partially oxidized, as you know, as I already told you. So there is oxygen molecules already present here. So that's why relatively it gives less calories whenever it is oxidized. Now let's move on to our next dietary molecule is the lipids, that is the fat. Fats are lipids composed of fatty acids. Basically, if you take a example of triacylglycerol, which is one of our major dietary lipid that in our body is the triacylglycerol, which is simply we call it as TAGs, triglycerides. Basically 3 fatty acids are attached to a glycerol molecule, and those fatty acids I have given here. So it can be a saturated fatty acid where you can see there is a hydrocarbon chain, there is only one oxygen, sorry, 2 atom of oxygen present here, other than that it is all hydrocarbon chain. Or if it is an unsaturated fatty acid, again there is a hydrocarbon chain, but there is a double bond here. So overall what I would like to say here is when you look at a fatty acid, whether it is a saturated fatty acid or unsaturated fatty acid, it simply contains very less oxygen. That means it is more reduced. So the fatty acid is more reduced here. So because of the reduced nature of this fatty acid, so whenever a reduced fatty acid here is oxidized into carbon dioxide and water molecule, so it is going to give more energy, it yields more energy than carbohydrates and the protein. So that is why, so the oxidation of 1 gram of protein will give 1 gram of fat will give 9 kilocalories of energy per gram. So this is much more than what we have seen with the oxidation of carbohydrates and the proteins. So this is what happens with the oxidation of lipids now. Now let's move on to see what is the energy that we get from oxidation of ethanol, that is the alcohol. So whenever alcohol is oxidized, so the alcohol oxidation into say acetaldehyde, acetaldehyde into acetate, and acetate further going into TCA cycle. So overall oxidation of alcohol into carbon dioxide and water molecule will give actually 7 kilocalories per gram of alcohol. So this is kind of in between carbohydrates and lipids, because carbohydrates give you I'll write it here for the sake of revision. So carbs oxidation into carbon dioxide and water molecule will give you 4 kilocalories of energy per gram, and oxidation of proteins into carbon dioxide, water, and ammonium ion. So it will give again 4 kilocalories of calories per gram, and oxidation of fats into carbon dioxide and water molecule will give 9 kilocalories per gram. So these are the numbers here. Make sure you remember these numbers. For alcohol it is 7 kilocalories. For carbs it is 4 kilocalories, for proteins it is 4 kilocalories, and for fats it is 9 kilocalories. So just to give you an example here, so what about a person if he or she consumes, say let's do some math here. So I'm going to give you the question here. So the question is, a person has consumed 100 grams of carbs. So carbs taken in the diet is 100 grams, and 120 grams of proteins. So person has taken 20 grams of proteins and say 15 grams of fat, and also additionally person has taken 45 grams of alcohol. Okay, so how much is the total calories that the person has consumed with all this? Say per day, if the person has consumed 100 grams of carbohydrates, 20 grams of protein, 15 grams of fat, and 45 grams of alcohol, so all you need to do now is just use those numbers. So as you know, carbohydrates give you 4 kilocalories, so 100 multiplied by 4, and then proteins give you again 4 kilocalories, so that means 20 multiplied by 4, so that is 80 there. And then like fat give you 15 grams of fat, so each gram of fat will give you 9 calories, so that means you get 135 there. And also alcohol give you 7 kilocalories of energy, and that means 45 grams multiplied by 7, so that means you are going to get around like 315 kilocalories. So if you add all of them together, so we have 5, so that is 10, so that is 0 here, and then we have 3 plus 1 is 4, 4 plus 1 is 5, 5 plus 8 is 13 there, so 1 here and 3 goes here, and then 4 1, that is 5, 5 plus 3 8, 8 plus 1, that is 9. So 930 kilocalories of energy per per day. So if the person has taken all this in a day, so that means total amount of calories that he got from that particular day is 930 kilocalories, or the 930 calories, simply saying calories. So this is how the questions can be asked related to energy that come from dietary fuels. So this is all about dietary fuels. So if you have questions, so let me know, and so that I can answer you in the comment section. So drop your question in the comment section. And again, so if you haven't subscribed to this channel, so kindly consider subscription, and also click the bell icon to get the regular notification. And also let me know if you have any request or any video that I need to make, and something that you have not understood, so related to biochemistry. So I will be glad to do that video if that request is for many of you. So that's about it, and I'm going to meet you in some other video. So in the link for that video, all the some of the videos are there in the description, and of course you can look at the channel, and I have made playlist also. So look at the playlist and also type whatever the video that you are looking for. So type that particular title or something like this, a keyword or something, and type Mungli or Dr. Mungli. So you will get that video. I have around like 270 videos. Obviously it will be there somewhere, and if you don't get that video, so let me know. I'm going to make the video on that, just in case if I haven't have that video before in my channel. So again, so thank you for watching. See you in my next video.